I am Agent Brewer with the FBI. Thank you for coming. There has been a burglary here at Mac Labs, and Dr. Mac is missing. We think he's been abducted. Clues at this crime scene will help us find him quickly. We have detected an international spice fraud operation here in Dallas. The perpetrators are adulterating pure ginger with allspice and turmeric and labeling it as pure. Recently, we sent Dr. Mac some of the ginger samples to analyze. If we know which contaminant he detected, we can narrow down the perpetrator. Turmeric is grown in Asia, and allspice is grown in Jamaica and Central America. Dr. Mac said he was analyzing the samples using a spectrometer. However, all of Dr. Mac's formulas, samples, and his prized spectrometer have been taken. I really need forensic scientists with equipment that can analyze the contaminated ginger samples. I have brought some samples from the same lot that I sent Dr. Mac.
Well, we have a spectrometer and a reflectance probe, and I know we can analyze those samples.
Great! We need you to process the scene quickly so we can identify who is running the spice fraud and then rescue Dr. Mac. Here are a list of suspects we have identified and their background. There may be a lot of clues in the lab, but we're waiting for someone with all the right equipment to help us before we started.
We've got this. We're from SMU.
Let's suit up and process the scene.
This is Dr. Mac's lab. Hey, this is unusual. Dr. Mac is such a stickler for safety. I know he wouldn't allow any food or drink to be on his lab bench. I wonder if this was the perpetrators. Since this is an aluminum can, and that's a non-porous surface, let's try cyanoacrylate fuming to see if we can get a print off of this can.
Sounds good. I'll get the super glue.
Okay, great. We'll use this as our fuming chamber. We'll put the can inside. And then we'll put some super glue, about 25 drops, on the top of the can. And then we'll moisten a paper towel and put that in our fuming chamber. Humidity sometimes speeds the process along. And I think that is good. It takes a while to do cyanoacrylate fuming.
Okay, we can speed up the process by putting it in the oven.
Great, thank you.
Now that we have that in the oven, let's see if there are any other clues around that could help us find Dr. Mac and identify the perpetrator.
Well, while you were putting that in the oven, I found an envelope addressed to the FBI, and it's empty. I bet it contained the identity of the spice that the ginger was contaminated with.
Let's process that for fingerprints.
Okay, since the envelope is a porous surface, I'll use ninhydrin. The ninhydrin will react with the amino acids from the fingerprint. And if there are fingerprints there, a nice purple ridge will form. It often takes a while. So sometimes we add a little bit of heat and then we just wait quite a while for the fingerprints to develop. Okay, there we go.
Agent Brewer said there could be evidence throughout the place. Since it takes a while for the fingerprint images to develop, I'll go check around while you use the ninhydrin.
Okay, great.
Hey, I think I found something.
Great, let's take a look.
This looks a lot like blood.
Yes, it does. Let's swab it and see if it could be blood using the Kastle-Meyer test. First, I'm going to take a swab and I'm going to moisten it with just some DI water. And then a little bit of ethanol. And then we'll roll the sample in blood. And then we'll add some Kastle-Meyer reagent. Now the Kastle-Meyer reagent is a reduced form of phenolphthalein called phenolphthalein. And when I add the hydrogen peroxide after this, if blood is present, the blood will oxidize the hydrogen peroxide, and then the oxygen atoms will in turn oxidize the phenolphthalein back into pink phenolphthalein. So there's our Kastle-Meyer reagent, and now I'm just going to add some peroxide. And if blood is present, or could be present, it should turn pink fairly quickly. And it does. I think this could be blood.
The blood is right around the carpet, so maybe we can check for that for more clues using the luminol.
That's a great idea. So when luminol reacts with iron in the blood, the luminol is oxidized. The electrons in the oxygen atoms are now in a higher energy state. As the electrons fall back to a lower energy level, they emit a photon, which we see as blue light.
Look, I think that it is a footprint. Let me measure it. What a small footprint. This might help us identify the burglar.
Kelly, please take a picture of that and the Kastle-Meyer test and upload this to the central SMU lab.
Okay, will do.
Look here. There's some powder on the floor. Let me take a sample of this and analyze it. It smells a little bit fruity. I think we can do a simple test and synthesize some esters to see what this compound may be.
Good idea.
Okay, good. Let's make oil of wintergreen and banana oil using a Fischer esterification. This is where we react a carboxylic acid with an alcohol in the presence of an acid, and we make an ester. And esters have a fruity or flowery smell, really a pleasant aroma. Okay, let's first synthesize oil of wintergreen. So I'm just going to follow the procedure that I have in my manual here, and I'm going to add a little bit of salicylic acid to my test tube. And I'm going to add 25 drops of methanol. And 10 drops of sulfuric acid. And then I'm going to mix it with a stirring rod. And I'm just going to place that in the boiling water, My oil of wintergreen is going to be on the left. And in the other beaker, I'm going to react and make some banana oil. And so what I'm going to do is I'm going to first add some isopentyl alcohol, 25 drops. And some acetic acid. And it also says some sulfuric acid. I'll just give that a little shake here and put it in the other beaker of boiling water. And we're going to let that react for about 7 to 10 minutes. Kelly, can you time that for me? And while we're doing this, I'm just going to make a solution that we're going to neutralize the acids into. Just simple sodium bicarbonate. And we'll just let those react for a little while. Okay.
Maybe by identifying what the unknown sample is, we can narrow down the suspects. I'm going to look up oil of wintergreen. It has a lot of uses. It's used in candy, bakeries, dental products, lotions, and as an insecticide. Let me look up the other ester while you're synthesizing banana oil. It's used in a lot of hair products and as an immune system supplement. This is interesting. Banana oil is used in Respirator Fit Tests. A vial of banana oil is opened when someone has a respirator on. If you can't smell the banana oil, you have a secure fit. If you can, you just need to adjust the respirator or find one that fits better. Let's compare the scents of these two esters to our sample.
Okay, we're going to do that in just a minute. But I remember that about the respirator fit test, because when I worked in industry, I did that and I could not smell the banana oil.
Interesting.
We're going to remove our sample from the boiling water and pour it into the beaker of water and sodium bicarbonate. I'm just going to wait for the bubbling to subside. Okay, we're going to do the same thing with the banana oil. Again, we're going to wait for the bubbling to subside. We're going to mix it a little bit. Okay, now we can compare our sample that we found on the floor This sure smells like oil of wintergreen. Can you please send this data to the central SMU lab?
Right, will do.
Now I think we can analyze the ginger samples? We can analyze them using our reflectance probe and spectrometer setup. Reflectance measures the amount of light that a sample reflects, and many compounds have their own fingerprint and can be identified from characteristics seen in the spectra. It's a quick method to determine what contaminant might be present.
Maybe by identifying the contaminant, we can identify what region the suspect comes from.
Okay, good. First we'll take the spectra of pure ginger, pure turmeric, and pure allspice. And then I'll combine all three of those spectra into one graph, and we can see their trends or their fingerprints.
That sounds good. While you are analyzing the pure samples, I'll investigate more on the background of these spices.
Okay. Okay, here's the allspice. And the turmeric. Okay, I'm going to combine these into the graph now.
This confirms what the FBI agent said. Turmeric is grown in Madagascar in southern Asia, and allspice is grown in Jamaica and Central America.
Great. Well, I just printed out a graph. Can you go pick that up, please?
Sure thing.
Okay, this is interesting. All right, let's take a sample now of the spectra of the sample that the FBI gave us. Okay, can you get the printout of that one too?
Let's compare the two. I think we know what was mixed with the pure ginger.
We sure do. Can you please send both of these to the central SMU lab?
Okay.
I think the cyanoacrylate fuming is done. Would you mind removing that from the oven?
Let's compare the fingerprints on the can and envelope with the fingerprints that the FBI gave us.
Great. We'll remove the can here. There's a really good print, and these developed nicely too. Why don't you take some pictures of these and upload them to the central SMU lab?
Okay.
Great. I think we have our answer. Let's go tell the FBI. We've analyzed the ginger and we found the spice that was mixed with the ginger. With all our analysis on the clues that we found in the lab, SMU was able to identify who took Dr. Mack and burglarized his lab.
We are on our way to their warehouse now. I bet that is where they are holding Dr. Mack. I am so glad you had the needed instruments and knew the right test to do on the evidence you found. Thank you, SMU, for such a fast and thorough job.